So this is a picture of Apollo 7 rising up from the launch complex in Cape Kennedy, Florida, Pad 34, the same launch pad where Grissom, White, and Chaffee died in the flash fire. And everybody knew that this was a crucial test of the new redesigned command and service module. Wally Schirra was the commander, a veteran of both Mercury and Gemini. His crewmates were two rookies, Don Isley and Walt Cunningham, and they felt absolutely committed to proving the spaceworthiness of that redesigned command and service module and vindicating the tragic loss of life of the Apollo 1 crew. In fact, Schirra at one point had even thought of calling his spacecraft the Phoenix, but in the end, it was an unspoken theme of the Apollo 7 mission. Well, they made it into orbit right as expected. They spent 11 days in space. They checked out all of the systems on the command and service module. They test-fired the service module engine several times. Of course, just keeping the spacecraft operating for 11 days was a very important workout of the spacecraft. And one of the highlights for everybody on Earth of Apollo 7 was that they used a lightweight television camera to send black and white video, TV transmissions from the spacecraft. And in this picture from their first telecast, you can see Don Isley on the left and Wally Schirra on the right. And Wally is holding a sign that was made by a friend, broadcaster friend named Mickey Capp, and record producer. It says, "Keep those cards and letters coming in, folks." Reference to the old days of radio shows that would say things like that in the 1930s and 40s. So all went well with Apollo 7. And that cleared the way for Apollo 8 to go around the moon. And not just to circle the moon in a figure 8, but to actually go into lunar orbit. And the crew for that mission, on the right, Commander Frank Borman, veteran of Gemini 7, commander of Gemini 7. And on the left, Jim Lovell, who was Frank Borman's crewmate on Gemini 7 and then went on to command Gemini 12. And in the middle, rookie Bill Anders. And there they are in front of the command module simulator in Houston. And they are looking ahead to literally being the first humans to leave planet Earth for real, not just a few hundred miles up, but 240,000 miles away. Meanwhile, there was some intrigue coming from the Soviet Union. They were launching a series of unmanned flights in a vehicle called Zond, which was basically a variant of the Soyuz. The Soyuz spacecraft, which you'll remember had been tried in April of 1967 and had ended tragically, killing the cosmonaut Vladimir Komarov. Now, in October of 1968, they did manage to test the Soyuz successfully on a manned Earth orbit mission with Georgy Beregovoy, and that went well. But even more fascinating for everybody who was paying attention to the Soviet program in the West were these lunar flights that were being used, unmanned flights that were being flown with the Zond spacecraft, which was a variant of the Soyuz. The one in September of 1968 actually carried several species of animals, including turtles and mealworms, and they circled the moon and returned to land successfully on Earth. It was launched atop a booster called the Proton, which is seen on the left. You can see at the bottom a rough schematic of the flight path, and you can see the Zond spacecraft is attached to a propulsion module that actually sent it on the trajectory around the moon. In November of 1968, they tried to repeat the circumlunar test flight of Zond 5 with Zond 6. But they had some problems, and premature deployment of the parachutes led to a crash landing. So you can imagine the cosmonauts who were waiting to do this themselves. Alexei Leonov was actually the commander of the mission. You'll remember him as the first spacewalker on Voskhod 2. Well, Leonov and his crewmate Oleg Makarov were hoping to fly a circumlunar mission of figure 8 around the moon and steal the thunder of Apollo. Now, even though that was not as complex a mission as orbiting the moon, it would still have been an enormous public relations victory. And so they had hoped to launch in December of 1968, but the planners were so skittish about another tragedy after losing Komarov that they did not give approval for Leonov and Makarov to take off on their own circumlunar mission. Meanwhile, in Houston, planning was going ahead for Apollo 8, and the mission design was very typical of the way NASA approached these missions. The whole flight plan was designed to provide as much safety as possible. It was a bold mission, to be sure, but it was not reckless. The goal was to go into orbit around the moon and spend 10 orbits around the moon, and this would give controllers on Earth the chance to track the motion of the Apollo spacecraft over the moon and thereby give new information on the variations in the moon's gravity field. The moon has kind of a lumpy gravitational field, and this actually causes tugs and pulls on an orbiting spacecraft that distort its orbit slightly and get it to go slightly off course. Well, it was very important for a landing mission and for all the rendezvous maneuvers that you'd have to do to have the astronauts rejoin after a landing. It was very important to understand the moon's gravity field very precisely. So that was the main goal of staying in orbit around the moon for 10 orbits, which would be about 20 hours. At the same time, of course, that would give the astronauts a chance to observe the moon close up, including the far side of the moon that always faces away from the Earth and is never visible from Earth. So they would become the first humans to see the far side with their own eyes, and they'd take close-up pictures of it. But, you know, the mission, as I say, was designed with safety in mind, and that's why they picked a trajectory that gave them the option to not go into orbit around the moon, not fire that big SPS engine, but instead just loop around the moon and come back to Earth. And it turns out that if you aim at just the right spot, you can use the moon's gravity to bend your flight path into a loop that sends you pointed exactly in the right direction to get back to Earth. This was called the free return trajectory, and it was one of the most important aspects of the mission design for Apollo 8. Because if there was any problem that happened on the way to the moon, they could always elect to not fire their big engine, and instead of going into orbit around the moon, they would loop around the moon in a figure 8 and come home. Now, even before they decided to fire that engine and go into lunar orbit, they would test fire the big SPS engine on the way to the moon, and they do it in such a way that they actually maintain the proper flight path. And by doing that test firing, they would actually know whether the engine was performing up to snuff, and they would be confident in the decision to go into orbit around the moon. Well, the big moment came on December 21st, 1968. Here you see Frank Borman suiting up. Here come the three astronauts out of their crew quarters. Here they are about to get ready into the spacecraft, and here is the launch of Apollo 8. That big Saturn V booster lifting off the pad, those big F1 engines lighting. Here you see a camera on the pad recording the enormous blast. Here's the rocket climbing past the launch tower and on towards space and into a clear blue sky and hopefully heading for the moon.